CITS section 1.5 is on solving inequalities. Now, if you came through our advanced algebra classes, you had some work in the solving of inequalities. If you came through our regular pre-calc class, you had a far more extensive background in solving these inequalities. In either case, there's going to be some problems in here that are a little bit new to you. Okay, so we'll start out with just our general rules in that, then I've got a few examples I can run through. In general, to solve an inequality, you want to treat it just like an equation, except when you multiply or divide by a negative number, you have to reverse the inequality sign. Now, technically, we do that with an equal sign also, it's just it doesn't show. So therefore, it's never really taught all the way up. But remember, we multiply or divide by a negative, you have to reverse the inequality. That's something that all of you should remember. The absolute value inequalities and the polynomial inequalities are when we start, and the rational inequalities are when it starts getting more difficult. Okay, an absolute value inequality. We're going to manipulate that until the absolute value is alone on one side. Then to solve, we write the inequality twice. Once as a positive value and once as a negative value. Because again, that absolute value is our distance away from 0. Okay, so if I start out with something like ax plus b is greater than c, I'm going to write it as ax plus b is less than c. I'm going to write it as ax plus b is less than c, and the opposite value of ax plus b is less than c. Now, we always teach it this way. The technically correct way, or we always teach it this way down here, where we just flip the inequality and negate the opposite side, or the constant. The technical way to do it is we're supposed to negate the left side. But if I run that negative through, or divide by -1, I end up getting that anyways. So I don't care which way you write it, as long as you remember that it has to be the opposite of one of the two sides and the reverse of the inequality. If I have ax plus b absolute value greater than c, again I'm going to rewrite it just by dropping the absolute values. Or, and again we always have taught this way, but this is the technical way. Okay, and I'm not too worried about you knowing both ways, okay? Now, to figure out what our actual solution set is, we use a diagram or a sign table to try and find that solution. And as you get into more difficult problems, some of the easier ones you can look at and you know what the solution is. Some of the more difficult ones you really need to use that sign set, that sign table. I want all answers given in terms of a solution set. Okay, whereas if you recall, we've done these a little bit before. If you find something that says that 3 is less than x is less than 12, that's my solution set from 3 to 12. Okay, if I run 3 is less than or equal to x is less than 12, that is now a closed set, so it's a closed bracket with the 3 and an open bracket with the 12. Okay? The polynomial inequalities. If they're a polynomial, okay, in other words, if they have an exponent, find all the zeros of the polynomial. Okay, stuff that we covered earlier in this chapter and in Algebra 2 and Algebra 1. Use the sign diagram to find the solutions, and then you have to use test values, and I'll go over some examples with that. A rational inequality is the one that's a little bit strange for us. We want to first of all get everything to one side. So I have to set the inequality so the ratio is all on one side alone. Okay, so it's going to be either greater than or less than or equal to 0. Combine all terms of the ratio. In other words, I have to add everything together, get it all as one ratio, and then find all the zeros of both the numerator and the denominator. And then we'll use the sign diagram. Okay, so they're all following basically the same rules. Okay, just as we add a little bit together. The big thing is with the rational one, something that most of you probably haven't seen, we have to get that ratio combined completely together. Okay, so I've got a few examples here, actually a couple of different pages of them. I'll try and go through the easy ones fairly quickly. Okay, so our first one is 5x plus 6 is less than 2x plus 1. I'm just going to solve it like it's an equal sign. Move the 2x over, subtract the 6, divide by 3. Being a positive number, I don't do anything with the equal sign, or with the inequality. Now I have x is less than -5/3. Now you can draw a diagram to help you out if needed. You don't have to for me. There's no equal sign, so it's an open circle. We're going less than, so it's going left. Now, this diagram tells me if x is less than negative 5/3, all the way to the left is negative infinity, and we stop at negative 5/3. There's no equal sign, so it's open. Okay, and there's my set notation. Number 15, the biggest problem a lot of times we have with people writing things out is they always reverse these inequalities. When it's a conjunction like this, when it's more than one inequality, reverse them before you start solving. It should make it a little bit easier for you. Now we can solve it all as one inequality. I can add 1 to all sides, to all parts of it. Now divide by 3. And that tells me x is in between 1/3 and 11/3 with an equal sign. So therefore, it starts at 1/3 with an equal sign, ends at 11/3, and there is my solution set. Okay, number 20 has two different parts. It has an or in between them. We solve these individually and then look at the solution set or the graph to try and figure our solution set. So I solve the left side. 2x, add 7 to both sides. So 2x is less than or equal to 22. So x is less than or equal to 11. Keep the or in place. 3x minus 1, so I'm going to add 1 to both sides and divide by 3. Now, I'm going to look at this inequality. I always like to put 0 on the paper so I know where 0 is at. There's 2 and there's 11. X is less than or equal to 11, so it's a closed dot going left. X is less than or equal to 2, so it's a closed dot going left. Now, the key to this is that it's an or. So as long as, I always say, as long as it's covered by one of these lines, it's in my solution set. So I'm going to write one solution set for the whole problem. Being it's an or, I only need one line covering it. So my solution set for this one, again, I go left to right. So out here, I'm out at negative infinity, and that's always an open bracket. Coming here, I hit 2, but I still have one line going to the right, which goes all the way to 11. So the solution set for this problem is negative infinity to 11. Now, just to change it a bit, if I were to change this to an and, same problem, but I change it to an and, my solution set would change because my and needs both values to be true for it to be a solution. So an and would start at negative infinity, come up to 2, and stop because the right-hand side isn't true for anything above 2. So the and would only be from negative infinity to 2. Okay, so hopefully that points out. Or we only need one of the lines to be true, and we need both of them. Number 24 is our first absolute value inequality. Again, we're going to write it twice. Okay, so I'm going to write, first of all, drop. Oops, I was going to drop that. X minus 10 is greater than or equal to 2. Now, being it's a greater than, okay, that's an or. So, or x minus 10 is less than or equal to negative 2. Now, I can solve each of these out. And being it's an or, it's both solution sets. So, x is greater than or equal to 12. Well, if you look at that, it starts at 12, and it's all the numbers bigger than 12. X is less than or equal to 8. So all the numbers less than 8, which goes to negative infinity, and it goes up to 8. And that would be our or. Okay? An or is also written technically as a union symbol. You'll see that in the answers in the book. Okay? Number 28, another absolute value. Now it's less than or equal to. Less than or equal to is an and. So I write it twice. 3 minus 2x is less than or equal to 5. And 3 minus 2x is greater than or equal to negative 5. Okay, I'm going to subtract my 3. Negative 2x is less than or equal to 2. Make sure when I divide by this negative 2, I reverse the inequality. Subtract my 3 again. Negative 2x is greater than or equal to negative 8. So x is less than or equal to 4. Now on these, I like to look at the graph because I've got x greater than or equal to negative 1. So this one's going this way. X less than or equal to 4. So these both go kind of like that, but I only look at where there's both of them. So my solution set with the equal sign is from negative 1 to 4. Okay? Now, if this had been an OR, if that had been reversed, my solution set would have covered everything. It would have been negative infinity to positive infinity. Okay, we got 3 more examples. These are of the more difficult type. Number 38. It's a polynomial inequality, which we know we need to factor first, find the zeros, and then use a sign chart to help us figure out what's going on. Okay, so I'm going to factor it first. Factor this into x plus 3, x plus 2 is less than or equal to 0. Find the zeros. So I know x equals negative 3 and x equals negative 2. Now, just make myself just a little graph just to keep things so I can kind of keep track of them. There's 0, there's negative 2, there's negative 3. I need to check terms on the outside and in between each of these zeros. So my check table is going to be anything that's less than negative 3. I just pick any number, negative 5. Has to be something between negative 2 and negative 3. So I'm going to pick negative 2.5. And then something bigger than negative 2. I'll pick 0. That's an easy one to work with. Now, all I'm going to do is I'm going to find the values of these. I like to plug them into the factored version because all I'm looking at is whether it's positive or negative. If I plug negative 5 in, I plug a negative 5 plus 3 is negative 2. All I care is that it's negative. Negative 5 plus 2 is negative 3. All I care is that it's negative. When I multiply 2 negatives together, I get a positive. That tells me out on this side it has to be positive. When I plug in negative 2.5, I get a positive and a negative. When I multiply those together, I get a negative. And when I plug in 0, I get positive and positive, which is a positive. Now, the original question wanted to know where everything is less than 0. In other words, where everything is negative. The only spot it's negative is right here, between these two zeros. So, it's negative, or the solution set happens between negative 3 and negative 2. And they're both open because there's no equal sign. So it's an open set. Okay. Number 48 is our first rational inequality. What I'm going to do, first of all, I need to get everything on one side. So I need to start this problem by going x minus 4 over x plus 6 minus 1 is less than or equal to 0. It has to be either less than or equal to or greater than or equal to 0. Now I'm going to combine these. So I have x minus 4 over x plus 6 minus, well, 1 is nothing more than x plus 6 over x plus 6. When I combine these, add my fractions, the bottom is x plus 6. I distribute the negative through, so x minus x is 0. Negative 4 minus 6 is negative 10. So there's my combined inequality. Now, what I need to do is find the zeros of both the numerator and the denominator. Well, the numerator zeros can't turn to 0. So there's no 0 in the numerator. In the denominator, it turns to 0 when x equals negative 6. So I technically only have one checkpoint. If I look at my graph, all I'm checking is negative 6. I'm going to check the left side of it and the right side of it. Okay, so my checkpoints, I'm going to check negative 10 and I'm going to check 0. Okay, I'm going to go back up into my simplified equation, and I could go back into the original too and compare it to 1, but I'll go back here. When I put negative 10 in, I've got negative 10 on the top and I've got negative 4 on the bottom, which is a negative over a negative, which is a positive. When I put 0 in, I've got negative 10 on the top, which is negative. I've got 6 on the bottom, which is positive. Negative over a positive is a negative. So therefore, on this side, it's a positive. On this side, it's a negative. We're looking for where it's less than. So less than is going to mean the negative. So it's everything from this point going that way. So my solution set starts at negative 6 and goes to infinity. Okay, last one. This one, a little bit bigger problem, but the same process. I need to get the factors, or find the zeros of both the top, the numerator, and the denominator. So I'm going to factor the top first, and you guys know how to factor, so I'm going to go a little bit quicker on this. When I factor this, I get x minus 2 times 3x plus 4 over x minus 1 is greater than or equal to 0. I'm then going to find the zeros of the numerator and the denominator. So therefore, the points I'm checking are when x minus 2 equals 0, so at 2, 3x plus 4 equals 0, which is negative 4/3, and the bottom, x minus 1 equals 0, which is 1. Okay, I'm going to put these over on my table, or my line here. So here's negative 4/3, here's 1, there's 2. So my checkpoints have to be 1 on the outside, in the middle, and on the right side. So I'm going to check something way over here that's easy to check, negative 10. Something in the middle that's easy, 0. 1.5 and 10. And again, all I'm checking is the positive and negative values. When I plug negative 10 in, I get a negative. Negative 30 plus 4 is a negative over a negative. So I get negative, negative over a negative. Okay, so once I have that, I know that 3 negatives gives me a negative. So that's a negative. When I plug 0 in, I get a negative, a positive, and a negative. 2 negatives make a positive, so in here it's a positive. When I plug in 1.5, I get a negative, a positive, and a positive. 1 negative makes a negative, so that's negative. And when I plug in 10, I get all positives. So now, as I look at my solution set, I'm looking where it's greater than 0. So I'm looking at the positive values from here to here and from here going out. So my solution set is from negative 4/3 to 1, and there is an equal sign. Whoops, so it should be squared off. Okay, and it's a greater than, so it's going to be an or. Starts at 2 and goes to infinity. Okay, so there is your quick lecture on solving inequalities and absolute value inequalities. Hopefully we got a good start to it. Let me know when you got questions.